Oh, hey there. Have you ever woken up and had tires that look like this? Yeah, that means there's probably a problem with your alignment. So we're going to swap out some of the steering components in here and then do the alignment on our bus with only two specialty tools.
It might be hard to see on camera, but normally tires are supposed to have a toe-in where they're sort of slightly angled inwards. This has a very massive toe out, and that's the reason why the old tires wore out so fast and got flat on us. So we're going to replace all the steering linkage parts, so the tie rods, the steering linkage, and the dampener, and then readjust it. Underneath I'm seeing the problem. The right tie rod, which is the adjustable one, it has a bend in it, which is causing the right tire to bow out more. So the current tie rods, it's all ball joints. We saw how fun these were to deal with when I replaced the spindles, and I went ahead and got the proper tool. Hopefully this makes life a lot easier, so we will remove the bolt, the nut on the bottom, put this in there and pop it out, and should be pretty easy just to swap the two out. Okay, so the spindle side came out really easy because remember we replaced the spindle, so that was not caked in there from years of wear. On the inside, I got the bolt off. The cotter pin was horribly in there, and now I'm going to use this tool to pop it out because I cannot pop it out by hand.
You okay?
Yep, it worked. That was much more violent than I was expecting. Next time, wear safety glasses. I was going to replace each thing one by one, but since taking the tie rod off, it gives much more access to the steering dampener, and it's kind of hard to see, but there's lots of gunk and oil built up from the years of this. Could be original. So I'm going to replace take everything apart, clean this up with some degreaser, and then we'll assemble it all back together with the new parts. Sorry, the air compressor got in the background, but now we have the steering linkage, which bolts down here from this arm that comes off the steering box and then goes to the back to where there's that steering fork thing that pivots forward and backwards with tie rods on it. So same thing, a ball joint on both sides that we got to remove, and hopefully not too explosive like the last time. This is adjustable, so what I'm going to do is pop this out, keep the steering wheel center when I put it all back together and align it, and then match the length of this one with the new one. The rear ball joint on the steering linkage, it's very hard to get to, and like the pulling direction, this tool would have to be up with the bolt up against wiring, and there's only access. So look, I had this puller, the teeth on it, like the jaws at the top, they're just ever so wide, so I put it on an angle so this arm, or this arm is resting on the lever arm, and this one's on the actual joint surface, so we'll see if this can pop it out. Okay, here are the old parts next to the new parts. All the new parts have their own bolts and hardware. The old tie rods, they used a cotter pin through a through hole and teeth on the bolt. The new ones have locking washers, so that's the change there. And then the dampener does not have its own hardware, so we're going to reuse those bolts from the previous one. Everything, we're going to match the lengths on this now, assuming that the original lengths were correct. Put them in, and then we'll work on the alignment. One thing to note, these new linkages, they have these plastic boot covers on them, so before you install them, make sure you remove that boot cover. That just protects the rubber boot on the ball joint, but if you install down there, you're going to have some problems, so make sure you remove those. Alright, it's all reassembled. What I did was set the fixed length tie rod side straight eyeballed with the car. Then I set the steering wheel in the centered straight position, and then based on that I adjusted the linkage here to length so that the steering wheel was straight and the fixed side was straight. You can see the right side, the driver's side, it's bowed out a little bit, so I'm going to eyeball that straight. Then I'm going to try to do the cant on the tires for the alignment, and then after that we'll put the tires back on and then work out the toe-in. Alright, so to adjust the left side, the lock bolts on both sides I did not torque down yet, but all you do is spin this to either steer it in or steer it out. So I'm going to do that off camera just so I can see what I'm doing. Okay, to get close to the proper camber, I'm going to use this magnetic electric angle finder, put it on the cross beam, find its angle and pick that as my horizontal, and then put this on the outer face of the brake rotor and then adjust the camber with that, and it should be, I believe, 0.67 degrees, so it's pretty tiny. So we'll see if we can get this ballpark. Again, this isn't professional. If anyone has any recommendations how to do this better, please comment below. I'm always happy to learn better ways of doing this and improving as I go. So I zeroed out this guy on the crossbar down there, and now we can see this is about 88.3 degrees. And then this giant crow's foot I bought, we put on that hex there after we loosen the ball joint a little bit, and then as we turn this, that nut moves, and you can see the vertical position of the tire, or the wheel is moving. That was the wrong way, so we want to get this about like 89.7, I believe, is the spec. So okay, we got it into spec, and then now we will just rotate this and check it at a couple different positions to make sure we're still good. 89.1 there, that's still within spec. And then up there again, 89.2, so this side's good. We'll torque that nut back down the back side and then do the other side and we'll be good to go. To refine the alignment a little bit better, I used this piece of straight 3/4 inch plywood, clamped it onto the outside face of each wheel, marked a line on the ground. Then I marked that line 1 foot from the center of the tire and 3 feet from the center of the tire, and then use that to measure the width on each side. So there actually still is a pretty significant toe out. So 1 foot from the center of the tire is 62 5/16, and then out here 3 feet from the center of the tire is 63 1/4. So I need to bring that in to get the proper toe in. As you can see, I made a couple adjustments, slowly moving that in to get the toe in that I wanted, and then using some simple trigonometry, I was able to calculate the angle that it is right now. So right now we have about 0.8 degrees toe in, which is not to spec, but it's as good as I'm going to get it right now. So that's what we're going to lock it in at. With the old tires being ruined and they're never actually proper tires weighed for this, we were able to get these tires, which is as close as we can get to the stock tire size. These are the Yokohama Supervan 356s, and this tire size is 195/75 R14 for the 14-inch rim. And these are light truck tires. You definitely want to get light truck or that weight rated because old buses are pretty heavy compared to modern vehicles. And then checking the height from the rear of our fender, we are just about 1 foot of ground clearance from the rear of the fender. If you remember from part 2, we started with 9 inches of clearance. Then we redid the front spindles to bring it back to the factory suspension height. That got us to 11 inches. And then these tires, they gave us 1 more inch. So we got 12 inches of clearance there.